Okay, so in this set, we're going to kind of delve into some of the properties for the cross product. What can we say is true? Now, this is a bit tricky because the cross product is non-abelian, so right off the bat, we don't get a full commutative property. We get that A cross B is equal to the opposite of B cross A, which means that these two vectors are going to go in opposite directions. They're going to be still orthogonal to both A and B, but one is the right hand and one is the left hand. Okay, so we do get a bit of an associative property here. If I scale A and cross it with B, that is the same as scaling the cross, which is the same as taking A and crossing it times the scalar times B. So that's a full associative property as far as the scalar is concerned. Okay, so we get a distributive property. If I take A cross B plus C, this is going to be equal to A cross B plus A cross C. So that's a distributive property. That's very much expected. Nothing unusual there. We also get a right-hand distribution. So if I have A plus B cross C is equal to A cross C plus B cross C. Now note, this has to be stated because normally we don't have to state the left and right hand versions of these because we have a commutative property. However, no full commutative property means I have to state both 3 and 4. Number 5, combining the dot with the cross, this is what we're later going to call the triple product, becomes really interesting. It literally moves the cross between the A and the B and the dot to the outside. Aha, that is not intuitive. This one we're going to take a look at a little bit later on in class. And number 6, A cross B cross C. So two cross products here, right? What happens? Well, this wickedly turns into a dot product, not B, C times B minus, of all things, a minus another dot product times C. So this also needs some sort of interrogation because that is definitely not trivial. All right, so these are 6 quick properties that we can get from the cross product. This starts the beginning of an algebra using the cross product. I want to call attention to 5 and 6 because these are not trivial matters, and make sure that we also understand that there is not, sorry, that's not supposed to be there, not a clear commutative property. So commutes becomes an opposite, which causes problems for the distribution, which makes the whole thing interesting.